This video is going to be longer and more scary than usually, because in it I'm going to talk about probabilities and mathematical ways to count if those probabilities are correct, so that we can check this code and how it is choosing random corridor out of 2, and we will be able to check how this code is choosing a random corridor out of 3. If you feel scared and you haven't understood everything after the end of this video, or even if you already are sure that you don't want to watch this, it's not going to be a problem. I'm not going to teach anything new in programming in this video, so you can skip to the end of it, where I will have find a small bug in this code. This code is looking so great, it's looking like it's working perfectly, but I will have to make a small change in it in order to understand what's wrong with this way of choosing a random corridor, and in the end you will be able to see very similar code and just use it. What I'm going to do at first is to check our old code generating a random corridor and placing the node on y300 or y0. In order to see if this code is working fine, I will create two new variables. I will call them nodes created in top corridor. In the beginning, I know about 0 such nodes, but with time I will find new nodes. And I will have one more variable called nodes created in bottom corridor. I need only two such variables because I have two corridors in this game. On this line of code I understand that a selection of a corridor is made, and I should increase one of these variables. When the new node is on y300, it's in the bottom corridor, so I will change nodes created in bottom corridor to 1 plus its current value. I will increase it by 1. I will also do this with the other variable, which should be increased when I create a new node on y0. So I will make this value increase. Let's see what is going on with those variables. You cannot see my variables. I need to type them in a console log, or I can write their names here. But it's not really easy to realize what is going on. Instead, I'm going to change one of the console logs. This console log is printed for each node resurrected. Whenever a node reaches the left end of the playing field, it should reappear on the right. And so I needed this console log to find the bugs about this. Now I don't need this console log. I can keep the message, or I can add after it the new variables that I need to be printed, or remove the text and leave only the new variables, nodes created in bottom corridor and nodes created in top corridor. Let's see what's going on with those variables. Well, maybe something strange is going on, because you can see that there was a long line of only creations in the top corridor. and with time it appears that there actually is not a problem, and the two corridors have roughly the same number of nodes created in them. Sometimes you can go to the wrong conclusion that there is something wrong if your sample size, the time that you watched nodes resurrecting, is not enough, and I can wait longer, or I can make the nodes run even faster. This is a crazy speed, it will ruin my game, but it will be useful for such a testing. And you can see that really fast I can reach the moment in which there are already 300 resurrections happened, and in this case I also have a slightly bigger number for the second printed number, slightly more nodes created in top corridor. If I refresh this web page, I can go to the exactly opposite conclusion in some moments. Or now I can see that sometimes they are equal, sometimes the bottom corridor is the preferred one, just like now. But my general conclusion is that now my code is fairly selecting a corridor, and I can expect some difference between those two numbers. With time, this difference disappears. If I try to make the same thing with this code for 3 corridors, I should be really careful. If you just create again variables, and this time we will need 3 variables, nodes created in middle corridor is a new variable that I will need, and also of course I will need nodes created in top corridor and bottom corridor, of course. So I should be careful with those 3 variables, because if I just write here lines of code that increase my variables by 1, I will actually fail to increase them in the correct moment. This is really strange. What I need to do now is write totally new ifs. So on this place I will write if node y is still 0, then this is the moment that I will increase nodes created in top corridor. I will have another if checking if the node is in the middle corridor. Notice that I always write 2 equals signs in the round brackets of ifs, because when I need to check if something is equal to 200, I cannot do it with 1 equals sign. This will change the value of the variable and will not check anything. So we will need such ifs. And after I have done all of this, I might be interested what are the values of those variables. Again, I will increase pretty much the speed of the game so that I can reach a good conclusion pretty soon. So I will make the nodes move with 300 pixels to the left, and I will want to know the values of my three variables on each key up. This is something interesting. What if this information, this statistic, is shown to me only when I need it? So yeah, I will write the three variables in the console, and let's see what happens. You can see that even so early there is too big difference, and the third number, the number that I print last, is nodes created in bottom corridor, is twice as big as the first number. So what could be going on? Why would this code have bigger probability than this code? Is there something wrong with 1 divided by 3 and the numbers that are smaller than 1 divided by 3 and the numbers that are bigger than 2 divided by 3? And why do I need it to make such a extra new ifs? Do you still don't believe me that those values here that I increase in such a manner will be different than another numbers that I might increase just here? Well, I'm sure that you don't believe me, so instead I'm going to create three new variables, and they will be called entered the top if, entered the middle ifs, because there are two ifs in the middle, and entered the bottom if. This is the value that apparently needs to be biggest in the end, because for some strange reason most of the nodes are created in the bottom corridor, or apparently this is what my strange statistics show. Well, I say that enterings of those ifs will not be the same as actual created nodes in the end, but I will show you now this. So I will increase entered the top if here. I will increase entered the middle ifs on this line. And finally, entered the top if will be increased here. Sorry, I made a very important mistake that could ruin my testing. When you try to check something that is already a mistake and you make a new mistake, this is really horrible. So when you have a mistake, please be very careful with your to not make any new mistakes. So entered the bottom if will be increased when we create a node in the bottom corridor. Let's see what are going to be the values that are created in this manner. So I'm going to print entered the top if, just I printed nodes created in the top corridor. Now I'm going to print nodes created in the middle corridor and the number of enterings in the middle ifs. I'm going to print nodes created in the bottom corridor, and finally how much times I have entered the bottom if. Just a reminder, if everything in my code was working fine, these two numbers will be equal, these two numbers will be also perfectly equal, and those two numbers will be also perfectly equal, and all of those 6 numbers will be really close together to around 1/3 of all the resurrections. Sadly, I can already see that this and this are big, and perhaps I will be surprised to see that those 3 numbers are totally different, and yeah, everything is wrong with my way to recreate nodes. Now you can see already that there is one number of times that I have created nodes in the top corridor, but a totally different number is the number of entering in this top if. By the way, you can see that actually the enterings, the times that we have entered those ifs are kind of close together. This is kind of good. For example, 53, 49 and 52 are really close numbers. So perhaps we enter those ifs a good number of times, but something wrong is happening, and in the end the actually created nodes are a different number. That you can see that after a lot of time we had the node in the bottom corridor many times, although that the creatings in the bottom corridor are only around 1000. The appearances of a node there are 1400, and although we had entered the first if 1126 times, a node has left in this corridor only 561 times. It looks like we enter this if but something after it is going on and changing node y yet one more time. This should not happen because to enter this code or this code we need a random number that is higher than 1/3 or even 2/3. How can a number that has already been less than 1/3 then appears to be bigger than 1/3 or even 2/3? Well, what actually happens is that each time we call mat random, even if it's in the same update, a new random number is selected. So we can have a small random number here and place the node in the top corridor, and after this a totally different random number is selected, and it makes those conditions true too. So our node is moved from the top to the middle or even the bottom corridor because of the totally new values for mat random that are selected. Well, it's time to show you the big solution of this small problem. What we really need is for each of the resurrections of a node to choose just one random number. It worked here if we had two ifs instead of a if and an else, and if we had in each of those two ifs a mat random, we will had again problems with nodes resurrection equally. So we can even ruin it when it has two corridors, and we also are able to fix it even when we have 3 or more corridors. For this I will need one more new variable. I will call it selected random, and this variable will just store a randomly selected number. I will need it because I will check a lot of different things for this selected number. I want to check each of the times I've checked it just for one and the same number, the exact number that is, and the only and exact number that is selected on this resurrection of a node. So this is why I don't need any mat randoms around those ifs. I need only one mat random in the beginning, and then check some interesting stuff about it in order to choose which corridor to have for the node. Let's see how this code is working now. I will wait a lot of time, and when I press a key I will see again 6 numbers. Those 6 numbers will show me how much times I have entered this if, how much times I have entered both those two ifs, and how much times I have entered this if. And I will also understand if those number of enterings of these strange ifs is the same as the final number of passages in a specific corridor. So I hope that I've waited long enough, and I can press a key and see that those two numbers are exactly the same. This means that exactly the same number of times that I entered this if, exactly the same number of times the node was left there and nobody moved it in another corridor. This is great. Also, those two numbers are exactly the same, and this is great. This means that I created a node exactly 496 times in the middle corridor, and it stayed there exactly 496 times. Also, those two numbers are exactly the same, and this is great. This means that I created a node exactly 478 times in the bottom corridor, and it stayed there. We had even another problem with our old code in which we didn't have selected random. When we were choosing a different random numbers, we had also the chance to select such a number here that we don't enter this if, then select totally different numbers here and don't enter this code, and then select totally different number here and we don't enter even this code. So in our previous buggy code we had the danger to not enter any of those ifs or to enter all of them. If we don't enter any of those ifs, we were left just with the previous corridor of the node. So if we create a totally different kind of statistical new variables, we can count the number of times when a node stays in the same corridor as the previous one. I will not going to do any more statistics, chill. I'm just going to show you that everything is now fine and you can select a corridor that is best for the computer or preferred. It looked like the bottom corridor was not liked at all, and there was the least number of times a node was created. But after a lot of time, it was the corridor with most nodes created. I don't know what is going to happen next, but I'm pretty sure that our selection of corridors is pretty fair, and I can just be happy with it and forget all about it and delete a lot of testing code. For example, delete this. I want my code to be small and simple again, and delete this console log, and delete all of those statistical variables. I will keep selected random because this is a variable that actually is the solution of my problem, and I can now be happy with my code. So you can keep this code, or, and this is going to be horrible and you're going to hate me for it, but yeah, we fixed this code with selected random, a variable that stores the only one random number that is selected for our new resurrection of a node. Can't we delete this variable that was the epic solution to our problem? Can we find another solution without such a variable? This is going to be your most evil homework task, but I don't want you to do this now. Instead, I want to stop this video now, and in the next video I'm going to explain to you why I write my code in such a strange manner.